So in my previous video I showed you how to make a small backfire antenna for 5.8 gigahertz specifically for FPV. Now I was really impressed with the performance of this little antenna, and straight away, as I said in that video, it was perfect, a perfect VSWR, and it was near enough perfect at center frequency. If you looked at that video, it was a little bit over to the right. I would have liked it a little bit more to the left spot on that curve there for the 5.8 gigahertz. But all in all, this was a lovely little antenna, and I started prototyping one before I'd even edited that video on how possibly I could make it a little bit better and make it out of say PCBs and etch the artwork that I could possibly produce and sell in my shop, and it wouldn't be until the new year. But this is what I've come up with. This one here, this is a PCB version of the backfire antenna. It's also a little bit smaller than the one that I made in the video. So in this video I want to go through how I made this, go over the artwork and show you how to put one of these together. So I'm not going to go into too much detail about measurements, etc., and how it works like I did in the previous one. Basically just talking about this antenna and why I'm quite excited about this antenna and the benefits that it could give you for FPV, especially over the helical antenna. So the backfire antenna has been around for quite some time. It even has its own Wikipedia page. But as I said in the 2.4 gigahertz version of this antenna, I didn't really see the benefits over something like a normal biquad antenna or a double biquad antenna. But this little antenna does have some pretty impressive benefits over other antennas, and one of those benefits are that for its aperture, its size, it really does make the most of the RF and outperforms similar antennas of a similar size. Now this particular antenna can be made quite big, and this is just a small form factor design that I've come up with. It can be increased in size to 5 wavelengths the diameter of the circle reflector. This is only 1.5 wavelengths in diameter, so it's only small, but even though it's a lot smaller, it still packs quite a big punch, and it has such a low VSWR because it makes such better use out of the RF than it's got coming into it. So if you had to compare this to say something in the real world, if you compared this to a middleweight boxer winning the heavyweight world championship but still weighing in as a middleweight, this is the antenna you know, equivalent of the boxer. Really, it really does punch well above its weight. So I think it's a real contender to the helical antenna for FPV, and it's quite simple to make as well. I think it's a lot more simple to make than say a helical antenna, where you've got to come up with something to keep those coils from, you know, bending out of shape, and you need to support those coils. So I'm going to go over the artwork and the PCB and how I came to cut this out, drill the holes and put this together into this construction that you see here. And I've also come to know this as the drum, because the way I've done the sides here, it does look a little bit like a drum. Now I've also done 2 designs on this, so I'll be including both in the artwork. You've got the normal design here with the driven elements on the front there, but I've also made this second one, which is often called an archery target backfire antenna because of this ring that's around here. Now this ring does have a lot of benefit. It works in conjunction with these 2 parasitic elements, works in conjunction with the back reflector, and you do get a little bit more gain out of this one than you do from this one. So I think if you're going to go to the trouble of making one, I would definitely make the archery target version, but I'll include both artwork in the download in the description below this video. So this is the artwork that I've produced that you can download, and there'll be a link in the description. And I've got three versions of the backfire antenna here. I've got the more traditional backfire antenna here, and I've got two versions of the Archery Target Backfire Antenna. Now this slightly thicker one is the one that I've settled on. It has slightly more gain than these two, although you know, you really need something like a network analyzer to view that gain, you know, in particular in the real world. I don't think you're going to see any difference between this one and this one in the real world, but I just think if you're going to go to the effort of etching your own, you may as well etch this one, because you know, it's taking no more effort to make than this one or this one. And it does have a slightly more gain, as I say, a little bit more gain than this one, and you know, very, very small amount of gain over this one. So as far as etching them out and producing them is concerned, I've used the photosynthesis method of etching. There are different methods out there, but photosynthesis is the one that I use. Some of you have given me some links to different kinds of etching, and I do want to try them out when I've got more time, because the photo etch board is a lot more expensive than plain old copper board. But I'm going to construct these two. Now I do find it a lot easier to drill all the holes first and then use the tin snips to cut these circles out, and then finish them off with a little bit of sandpaper or the Dremel. So what I'm going to do first is drill the holes in this one here. This is the one that I'm going to produce, the Archery version of the antenna, and then I'll show you how to put all this together and you know, solder it all up. So I've got the holes drilled out now in the PCB, so what I'm going to do is cut them out with some tin snips and then finish them off with some sandpaper or the Dremel. One thing to note about the artwork, these two holes here, I haven't drilled those out because there's no need to have those holes anymore. I attach the parasitic elements, the nylon spacers, directly to the top here, so there's no need for those two holes. So if you want to colour those in the artwork before you develop your PCBs, I would suggest you do that, but I've just not drilled them out for now, and I'll leave them at that rather than etching another PCB just for this video. And using some tin snips like these ones are made by Stanley. They didn't cost a great deal of money. I got them off eBay, and what I'm doing is just trying to get close to that copper edge here, the circle, but not too close to it, because I'll take in with the sanding block and the Dremel tool to really do a nice neater job. That's one that I've already cut out there, and I want this copper line here to stay in place, because that is going to be used to anchor down the copper tape that we're going to use to fill in the side. So just take your time and a decent pair of sharp tin snips, and you'll be fine. It doesn't take too long at all to cut the circle out. And just try and do it in little chunks like this. Don't try and go all the way around in one go. So now that we've got it cut out with the tin snips, just use a sanding block. This is a medium sandpaper, and just work your way around it, sanding it nice and smooth. So both of the PCBs are prepared and finished now, but there's two small holes that I need to drill before we move on to the coax and the balun, and that's in the elements themselves, so I can attach the coax to these two elements. So I'm just going to use a 1mm drill bit to drill the hole for the coax to go through. And as for the balun, I'm using the exact same method as I used in the previous video, just some tubing here with a slot cut into it 1/4 wavelength long. But I am going to mount this one with the copper side of the PCB on the outside, so when you measure your balun to get it at the correct height to solder it in place, you have to take into account of this 1mm thick PCB here. So now I'm ready to fit the nylon spacers that are going to sandwich the two parts of this antenna together. And what I've got here are some M3 nylon spacers, and I picked these up off eBay. I just picked a assortment box up here because I wasn't sure which size I was going to end up using. But these are 15mm long, and I'm going to connect those in place with these little M3 screws that you got with the kit as well. So put all those pillars in place, and then we can solder the main element on, and we can sandwich that on the top there. So I'm now ready to solder the coax onto the driven element part of the PCB, and I just wanted to point out that I've designed this one to be left-hand circular polarized because it leads off with the longest leg first. Now I could flip it over if I wanted to make it right-hand circular polarized, and that way it would lead off with the shortest leg first. But because I'm going to be using some copper tape to build the sides up, I won't have anything to solder it down to. So that's why I've got this outer ring here, so I can solder the tape to it and make a really secure job of it like I have on this one. But if you wanted to make a right hand circular polarized one with the artwork, you can just reverse the artwork as a PDF and then print it out onto your transfer paper or however you're going to do it. But this is going to be a left hand circular polarized one. So I've basically got to get the two lengths of coax there through the two holes in the PCB, so it's a little bit tricky. It's like threading a double needle backwards, but it's not impossible. And I'm not going to be able to do it with the camera, so I'm going to have to put my glasses on and just pause the camera. So I've got the coax threaded through those two holes, so what I'm going to do is put a couple of screws in this top part of the PCB here so it doesn't move around, and then I can solder those in just like you would a through hole part. And before you do solder them in place, just eyeball it and double check that you haven't got a short in those two coaxes there. And to hold it steady while I'm soldering those 2 points on there, I've often said in the past that the humble roll of masking tape is probably one of the best and useful things that you can have in your lab. Now when it comes to prototyping antennas and making them, this is the kind of thing that you figure out the more you do something. And I should have really put these spacers onto these two holes here, connected them up before I soldered the coax onto the driven elements there. But these are 20mm long spacers. I'm using these nylon spacers with the thread at one end because I'm going to put one through one of those holes, and what I'm going to do is use my needle nose pliers, hold one of these nuts in place while I screw this down to tighten it up. I should have really done that before I soldered these in place, but you know, when you're prototyping antennas, that's the kind of thing that you iron out the more you do it. Now for the parasitic reflectors, I mentioned in the previous video that it might be a good idea to try and find some 20mm washers and some 12mm washers, and I have since done that, as you can see here. And the 12mm washers I don't have to do anything with because the hole is already through there, but the 20mm ones, you do have to drill a hole either side of this center hole. Now what I did, even though I've got a drill press, took me a few attempts to get one that I was happy with the holes that lined up. So the one that I was happy with, I've kept that as my little jig, and I found I can repeat this quite accurately time and time again. If you keep a really good one that you've managed to drill the holes through, and then use that as your template jig, get one that you need to drill the holes through, hold them both together with a nut and bolt like this, and then you can use those holes to guide your drill so you get repeatable drilled holes in these washers, because even though they're mild steel, they are a little bit tricky to drill the holes. I do want to find some of these that are possibly copper or even brass, be a little bit softer and a little bit easier to drill, more than it being a better parasitic element. But this works out a lot better than trimming them with you know, some tin snips or scissors out of some tin. But it is tricky to drill those holes, so once you get a really good one, save that as your little guide jig, and then you can repeat it quite easily time and time again by bolting a plain one on the back of this, and then using those two holes to guide your drill bit. So before I fit the first parasitic element, what I'm going to do is use another 20mm spacer, and I'm going to bolt that one onto there and then bolt that onto these two pillars on the antenna. So that's the two parasitic elements in place. So I'm getting ready now to put the copper tape around the antenna, but before I do that, this is the base of the balun with the coax feeding in, and you can probably see it's a little bit loose in there, and that'll be a fail factor in the future. So what I'm going to do is pour a little bit of epoxy down there just to make it more solid and hold it in place, and then put some heat shrink tubing over the top. So next I'm going to use some copper tape to fill in the sides of the antenna like I have done with this one. Now this is from the garden centre, it's 2 meters long, and it's just a little bit shy of 25mm wide, so it's just wide enough to fit on the side and have a little bit of overhang top and bottom, so we can solder it permanently in place. So you don't want to peel all the tape off in one go, you want to peel it back in small chunks and just work your way around the antenna, trying to get it nice and uniform, and really take your time to get a good starting point as well, because if you get that straight, that'll kind of guide the tape all the way around the antenna. And then work it in with your thumb just to get it well stuck down on those edges. And it also smooths out a little bit when you do this as well. And once you've got the edges stuck down, you can just use your finger and just smooth out the rest. So what you'll end up getting is a small curve indentation in the sides here. So now what I'm going to do is flood some solder on the edges, just so we've got a really good connection there, because at the moment it's just the sticky back tape of the copper tape itself. So to make sure we've got a more permanent connection, a little bit of solder and just flow it around that edge. And you just repeat and flow solder on the front of the antenna as well. And to finish it off, I'm going to use one of these little right angled bends that I've tapped out with a thread so I can connect it to a tripod. So I'm just going to remove this screw here and then fasten it in place using that screw again, and then drizzle a little bit of super glue around the back of this, because this screw is only plastic nylon, so it doesn't do the best job of holding it in place. So it's a really simple setup to measure the VSWR of the little backfire antenna here. I've got the sweeper sweeping from 5 GHz up to 6 GHz, and it's coming out of the sweeper here, and I've got a reference detector for the network analyzer coming from the output. And then we've got the RF coming along here into the directional coupler, going into the small antenna here, and then any reflections from that antenna, because if there's any mismatches, it will reflect power back down the line again, and this detector will pick up any reflections, and it's those reflections that are measured to give us the VSWR. So here's the VSWR for 5.8 GHz then, and it's really low, 1.001 VSWR. It's almost bang on in the middle of 5.8. It's probably 5.855 gigahertz, right there in the middle. And I've also, because I've etched this, I've made the tracks on the driven element that little bit wider, so it opens it up a little bit, so we've got a good response throughout 5.8 gigahertz there. And you wouldn't be able to do that if you weren't etching. It's probably next to impossible and almost down to luck if you want to try and tune it to that specific response there in the 5.8 gigahertz band using hand tools. This is something that you can only really do if you etch out the main driven elements. So to be honest then, I don't think I can do much more to improve this antenna. It's almost perfect right there. I mean, the previous video with the one that I made by hand, I mean, you know, that's as perfect as you could probably get it by making an antenna using hand tools like that. And this is the next step of etching onto PCB, so you can really, you know, get the measurements down to like 1/4 of a millimeter and 1/2 millimeter. But yeah, it's turned out really well, and it can often take months and months of prototyping and testing to get it down to a response like this. So I've been quite lucky with this antenna, with the measurements, getting it you know, so precisely on target there, with very little effort, making different prototypes and spending a lot of time testing. So here's the evolution of the backfire antenna, if you like, and this hasn't taken a lot of work to get to the finished product, because it is a established antenna, so I didn't have to go into the mathematics of it and start doing different prototypes of the main driven elements. And people have asked me before, do I use software to prototype the elements to get the measurements? And no, not really. I do a basic calculation with the calculator, and then I like to actually make a prototype, test it, and then if that doesn't work, make some alterations, build a prototype and test it again. And I do make a great many prototypes out of cardboard. This isn't a working prototype here, it's just to get a feel of the dimensions and the finished design that I was aiming for. But I have built them out of cardboard before, using copper tape for the elements. You can do that, it's really simple. And as I say, it hasn't taken that long at all. These two here from the previous video, using the cooking tin as a reflector, I mean, these do work well, and they also look quite good as well. But it's come along here to this one that I've finally settled on, and the one that I've just shown you how to build in this video. So I hope you enjoyed this video, and please feel free to download the artwork and build one for yourself. And if you do, please feedback to us and tell us how you got on and how well it performs in the real world. But if you did enjoy this video, please give it a thumbs up. Comments and questions, drop them below. I'll do my best to answer them, and hopefully you'll join me on the next one.